Hi, welcome back to Unit 8, Lesson 2 of Algebra 2. We're going to be simplifying rational expressions today. So simplifying a rational expression, and again, rational just means fractional because a rational expression is anything that can be written as A over B. A rational number is the same way, any number that can be written in the form of A over B. So don't flip out when you see things that sound like they're more complicated than they really are. So simplifying a rational or fractional expression into its lowest terms is an extremely useful skill. Its algebra is based on how we simply simplify numerical fractions. So in exercise 1, so when we're going to be simplifying, now this is an algebraic fraction. Most of the time it'll say a rational expression. But we're just going to factor both of them. Because if you think of how we factor something like, let's say 12 out of 15. You don't realize you do it this way, but 12 is 3 times 4, and 15 is 3 times 5. And we get rid of the 3's. Now final answer is 4 over 5. So you didn't realize it, but that's how you kind of reduce fractions in your head. So this is not much different. So we're going to reduce the numerator. This is a difference of perfect squares. So it's x plus 3, x minus 3. It does not matter which order you write them in. And in the denominator, you're going to factor out a 2, a GCF of 2, and you get 2x plus 3. And when they're telling you to simplify, you should be ending up with something where you have 2 of the same thing. All right, so in this case, you have to make sure that they're protected. In other words, I can't just get rid of the x's. We can't do anything like this, like just getting rid of the x's, and maybe just getting rid of the 3's. Oh, we're left with 1/2. No, that's a big no-no. So let's get rid of all of that. All right, so my final answer here is what's ever left in my numerator, which is x minus 3. What's ever left in my denominator, 2. And if you wanted to, you can keep that x minus 3 in parentheses, because what that does is it kind of reminds you that it's protected. You can't simplify into anything with a plus or a minus sign. Okay, so keep that in mind as we move on to exercise 2. Simplify each of the following monomials dividing other monomials. So we're kind of taking a step backwards here. So I'm just going to remind you what this means. It means, let's see, 3 times 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4, 5, 6 y's, all over. Now, I don't expect you to do this, just I'm making a point here. All over 6 with 8 x's and 3 y's. So I want you to think about it like this, because this is how we're going to be thinking about canceling our polynomials or binomials in our next part of this lesson. So the first thing we do is we're going to reduce those numbers. So 3 over 6 reduces to 1 over 2. All right? So now how many x's are we canceling out, and where are the x's going to be left over? Well, we're definitely going to have more x's in the denominator, because I'm going to cancel out 1, 2, 3, 4, 5 of them. So I'm going to be left with 3 left over in the denominator. And then I'm going to cancel out 1, 2, 3 of the y's. But now I'm going to be left with 3 y's in the numerator. So my final answer here is y to the third, usually drop the 1, over 2x to the third. So when I think about this, the first thing I think to myself is, where is the larger exponent and where am I going to have x's left over? So when I move on to b, the first thing I'm going to do with b is I'm going to think to myself, well, 20 divided by 4, and I'm just going to reduce that. Put my fraction bar up just to keep me organized. So this becomes 5 over 1. Now, I look at my exponents of my x's. I have more in the numerator, so I'm going to leave it here. And 10 minus 2 is 8. And the y also stays in the numerator because I have nothing to cancel it with, which is y to the 8th. So my final answer here is 5x to the 8th, y to the 8th. You can put the whole thing over 1 if you want to, but it is not necessary. Moving on to C, we're going to take a look at those numbers first. 7 over 21 reduces to 1 over 3. Now I look, see how I have my larger exponent in the denominator? So I know I'm going to have x's left over down at the bottom, and 5 minus 3 is 2. We're going to put a 1 here because sometimes we forget about that one. We have more y's in the denominator, so it's y to the 7th. So that's the answer to this one, and you can move that 1 over if you want, so it's in the middle, like this. And I also want to remind you that how another way we can write this, earlier in this year we talked about this. When the x's are in the denominator, you can rewrite it as x to the negative 2, y to the negative 7 if you bring them up top. Or you could even write it as x to the negative 2, y to the negative 7 over 3, another way. So these are all ways that you can write the same exact expression. Moving on to exercise 3. Of course, at any time, please pause. You know that. If I'm going too fast or I'm just moving on too quickly, just pause the video and catch up to what I'm up to. So exercise 3 is a multiple choice, which is lovely, but be careful. They're not always your friend because a lot of times they look alike. So the first thing we're going to do is reduce the 10 over 15, reduce it by 2, and we get 5, oh, by 2, by 5, and we get 2, I was thinking 2, and we get 2 over 3. So give that a little bit of thought. Make sure you're right, because if you are, you can move on to your answers and say, well, I know it's not this one, and I know it's not this one. And sometimes it's really nice when you do a simple step like that and you can get rid of 2 of your answer choices. Kind of gives you a little more confidence to go ahead and forward with the question. So now let's look at our x's. We have the larger x in the numerator, so the x is going to stay here, x to the 4th power. And we have the larger y in the denominator, so we're going to get 6 minus 3 is 3. So x to the 4th, y to the 3rd. I look at both answers to make sure I'm not picking the wrong answer, because it's happened way too many times where somebody shows their work, they have the right answer, and they pick the wrong answer choice. It's like a knife through my heart. It so upsets me. So make sure you're being very, very careful when you're doing that. I think that's it for this page. Moving on. So now we're going to start getting a little bit more complicated with rational expressions. And that means we're going to be factoring both the numerator and the denominator instead of just multiplying them out with x's. So I always like to start with the easier one. So when I take a look at A, I'm very good at factoring dots, like I'm sure you are too. So when you see a dots here, difference of perfect squares, in your denominator, and I see a perfect square and a perfect square with a minus sign, difference of perfect squares, I know that when I create this, x and 2 and 2, and plus and minus, and it doesn't matter where that plus and minus goes. Now I'm going to move into my numerator. And this is not bad because the leading coefficient is 1, which makes things so much easier for us. So x and x. The numbers that multiply to 14 but subtract to give me 5, because this is where I'm right here. Numbers that multiply to 14 but subtract to give me a positive 5 is 7 and 2. And I know I need a positive 5, so I know this has to be a positive 7 and a minus 2. So I get plus 7 minus 2, which is a positive 5. And this makes sense because I want to be able to cancel out 2 of these. I want to be able to say minus 2, minus 2. So x minus 2, remember, they are exactly the same and they're protected. So I can only cancel out what's in the parentheses if they're exactly the same. So my final answer is x plus 7 over x plus 2. And I keep them in parentheses unless it's multiple choice. And then, of course, the answer x plus 7 over x plus 2 would be the answer in the multiple choice. It just stops me from wanting to cancel out those x's. Because some people might want to cancel out those x's and say, oh, the answer is 7 over 2, which is so not right. Okay, so going on to B, I would probably factor the top first because, like I said, I'm very happy doing difference of perfect squares to get 2x minus 1 and 2x plus 1. And the bottom is just a GCF. I'm going to factor out a 5 and get 2x minus 1. And when I know I have something that I can cancel out, I know I probably did it right. So these will cancel. My final answer is 2x plus 1 over 5. And again, you can keep these in parentheses to keep them protected. And this last one, factor out, do the x plus 4, x minus 4 as your dots. Now, see how this one has a leading coefficient of 3? So that kind of flips people out once in a while. But I know it's 3x and x because 3 is prime. So I only know it's 3 times 1. But here's kind of a little trick. I know one of them I'm going to have to cancel with this. So I know that if I have x plus 4, x minus 4, the 4 is probably going to go here. And if I'm trying to get to a positive 8, I know the 2 is going to go here. The signs are the same. They're both plus, so they're both positive. Give it a quick check. You get a positive 12 and a positive 2, which is a positive 14. And now, yes, these cancel. So my final answer is 3x plus 2 over x minus 4. So moving on to exercise 5, I'm going to start with something really simple, and that's by just looking at what happens when we take a difference and we switch it around. So 9 minus 6 is 3, and 6 minus 9 is negative 3. So this reduces to a negative 1. 15 minus 3 is 12. 3 minus 15 is negative 12. So this also reduces to a negative 1. So what I'm hoping that you're seeing here is that whenever we have an A minus B, and then we have a B minus A, remember the commutative property does not work for subtraction unless you say it's equal to a negative 1. So let's take a look at some of the examples that are coming up here. So factor the numerator, which is 2 times x minus 5, and the denominator. And I'm going to remind you, when there's a DOPS and the 25 is first, order counts. So it's going to be 5 plus x and 5 minus x. Now I'm going to remind you that 5 plus x and x plus 5 are the same thing. So if you had them, they would just cancel to positive 1 because they're exactly the same thing. In this case, when we cancel out our x minus 5 and our 5 minus x, they're not the same thing. We have to multiply one of them by a negative. So this answer would be negative 2 over 5 plus x, or we could write it as negative 2 over x plus 5, or you could actually keep the 2 positive in the top and make the whole bottom negative. So it should be 2 over negative x minus 5. So all 4 of these mean exactly the same thing. But as you can see, here is our answer, negative 2 over x plus 5. Sometimes we need to manipulate our answer choices in order to match it to what we've got. All right, so moving on to exercise 7. Fraction bar. Crooked fraction bar, but a fraction bar. All right, so I know I'm going to factor this. Let's start with the bottom. I think it's easier because I can factor out a 6, and I get 3 minus x. And the top, I can see I'm going to have x and x, So I'm going to assume one of these is probably a negative 3. So if I put a 3 here and a 3 here, the signs are the same, negative, negative, right? So I get negative 3x, negative 3x, negative 6x. That's right, plus 9. So now when I cancel these, remember I can only cancel one of them because anything over itself is equal to 1. So I can only cancel one of these, and I'm going to multiply one of them by a negative 1. So what I just got right now is negative 1, x minus 3 over 6. Now I don't see that there anywhere. So if I distribute this out, I get negative x plus 3 over 6, which I'm still not seeing anywhere. I see negative x minus 3 in number 1, but let's flip it around, because now if I put the 3 first minus x over 6, now the answer choice becomes apparent or obvious. So that's the end of 8.2. You're waiting for me to say it, aren't you? You're waiting for me to say it. Make good choices. I'll see you next time.